Hey everyone, we are starting today with a perspective that fundamentally changes how we think about what we are seeing. Because the latest images of 3I Atlas are not coming from Earth based telescopes and not from near Earth orbit. They are coming from a spacecraft operating deep inside the Sun's environment. NASA has released new images taken by the Parker Solar Probe, and these frames place 3I Atlas inside a region of space where conditions are extreme, dynamic, and unforgiving. That context matters immediately. The Parker Solar Probe was never designed to observe comets or interstellar visitors. Its mission is to study the sun itself. It flies through the corona, samples the solar wind directly, and measures magnetic fields and energetic particles at distances no spacecraft has reached before. So, when an object like 3I Atlas appears in these images, it is not just another point of light. It is material from another star system being observed while immersed in one of the harshest environments we can directly measure. This is not a distant snapshot. This is not a quiet background. This is an active, high-energy region of space, and that changes how every detail should be interpreted. Now let us slow down and carefully describe what the Parker Solar Probe images actually show. In the latest frames released by NASA, 3I Atlas appears as a compact and luminous source. The brightness is concentrated toward the central region. It does not smear outward into a diffuse, chaotic cloud. It does not fragment into multiple pieces. Instead, it maintains a coherent, recognizable structure even while surrounded by intense solar radiation and particle flow. This alone is notable. Objects that pass this close to the sun often show violent responses. Dust clouds expand rapidly. Ionized material interacts strongly with the solar wind. Brightness fluctuates as material is stripped away. Features distort, stretch, and sometimes disappear entirely. Here, that kind of instability is not dominant. The coma remains controlled. The brightness profile remains steady. The object retains its identity against a complex solar background. Now place this observation alongside what we already documented during closest approach to Earth. Around perigee, Earth-based imaging revealed dramatic geometric effects. Anti-tail rotation unfolded night after night. The apparent orientation of the tail changed rapidly as Earth's viewing angle shifted. But even during that rapid geometric evolution, the underlying signal remained consistent. The structure stayed clean. The brightness remained stable. There was no sign of chaotic shedding. The Parker Solar Probe images reinforce that same pattern from a completely different vantage point. This is not an Earth-based illusion. This is not a quirk of ground processing. This is not something that vanishes when we change instruments or environments. It is consistent behavior observed across radically different observational regimes. And consistency is where science becomes confident. Now, this is the point where the discussion connects directly to A.V. Loeb's latest post, riding 3I Atlas to the stars. The phrase is carefully chosen. 3I Atlas is not gravitationally bound to the sun. It is on a hyperbolic trajectory. It entered our solar system from interstellar space, passed through the inner regions, and will continue outward, eventually returning to the vast distances between stars. Avi Loeb emphasizes that interstellar objects are valuable not because they are mysterious, but because they are rare physical samples of environments we cannot otherwise study. They carry information encoded in their composition, structure, and response to radiation. They are records of processes that occurred around other stars. From that perspective, the Parker Solar Probe images take on added importance. They show how interstellar material responds when exposed to a star like ours at close range. They show whether that material disintegrates under thermal stress, reacts violently to solar wind interaction, or maintains coherence as it passes through an unfamiliar environment. And in this case, coherence dominates the signal. That does not mean nothing is happening. It means the interaction is measured rather than explosive. And that distinction matters deeply. A violent response would suggest fragile material dominated by easily liberated volatiles. Rapid fragmentation or flaring would indicate weak internal cohesion. Instead, what we see is behavior consistent with larger dust grains, stronger binding, and a thermal history that may differ significantly from many solar system comets. Now combine this with everything else we have observed so far. Multi-night imaging showed rapid anti-tail rotation driven by geometry, not turbulence. Closest approach data showed clean structure instead of chaotic mass loss. Space tracking analysis flagged low interaction behavior. And now Parker's solar probe imagery confirms that even under intense solar radiation, 3I Atlas retains structural integrity. These observations are not isolated data points. They reinforce one another. AV Loeb's framing invites us to think beyond this single encounter. 3I Atlas is only briefly interacting with our solar system. On cosmic timescales, this passage is a blink. What we are witnessing is a natural experiment. How does interstellar material behave when it encounters a new star? How does dust formed in another system respond to unfamiliar radiation and magnetic fields? How resilient is that material when exposed to conditions it has never experienced before? So far, the evidence points toward resilience. And this is where scientific discipline becomes essential. None of this requires extraordinary claims. None of this implies artificial origin or intent. None of this demands speculation beyond what the data supports. What it does suggest is that our existing categories may not fully capture the diversity of interstellar objects. 3I Atlas does not behave exactly like classical solar system comets, and it does not match previous interstellar visitors perfectly either. It occupies a space between categories, and that space is where new understanding forms. The Parker Solar Probe images do not answer every question, but they remove some possibilities. They show us what did not happen. There was no catastrophic breakup. There was no violent outburst. There was no sudden loss of coherence. And in science, absence of expected behavior can be as informative as its presence. As 3I Atlas continues on its outbound path, moving away from the sun and gradually returning to interstellar space, these observations will become benchmarks. Future interstellar objects will be compared against this one. Similarities will strengthen models. Differences will force revisions. For now, what we can say with confidence is this: 3I Atlas entered the solar system. It passed close to Earth. It traveled deep into the sun's environment, and it emerged from that passage still structured, still coherent, and still carrying information from beyond our system. We do not need final answers today. We need careful documentation. We need continued observation. And we need comparison across future events. Instrument perspective matters, environment matters, and context matters. This is how interstellar science progresses, not through certainty, but through accumulation of evidence. One brief encounter at a time. Let me know what stands out to you most from the Parker Solar Probe images. And if you are following AVI Loeb's latest discussion about writing 3I Atlas to the stars, stay with it. The object may be leaving our system, but the data it leaves behind will continue shaping how we understand the next visitor that comes our way.